Okay, student. Now we are going to see the last point from the unit first, the law of rationality of indices. Law of rationality of indices. Law of rationality of indices was put forth by a French mineralogist, R.J. Huy, in 1784, as it is possible to choose along three coordinate axes unit distances, that is A, B, C, which may or may not be of the same length, such that the ratio of three intercepts of any plane in a crystal is given by MA as to NB as to PC, where M and P are integral numbers. In other words, all faces cut a given axis at a distances from the origin which bear a simple ratio to one another. All faces cut a given axis at a distance from origin which bear a simple ratio to one another. So here now on in this slide you may get means you will feel quite the thing as like it is somehow complicated. Okay, but when we proceed to the next slide, it is very simple, very simple. Okay, this law is put forth only to explain how any plane cut three axes, that is the x-axis, y-axis, and z-axis, and how that plane appear on the three dimension. Okay, to explain that, the law is explained. Now see, here it is. Two planes are there, plane A, B, C. Okay, and one more plane is there, D, E, F. D, E, and F, right? So now OA, OB, and OC. See here, the distance is A, B, C along the three axes. Okay. Now see here. Remember this. Remember this. Huh? Remember this diagram. Now see here. See OX. Here it is on x-axis. OY, right? And here it is. Let me. Is my pointer? I'm not able to. Yes, okay, here it is. Here it is. OZ. Okay, and here it is OX. Let me change the color because it's not visible. Okay, okay now. Now see, this is OA here. This is A, this is B, this is C. Okay, this is one plane now, which is cutting three axes. This is another plane, DF, which is cutting these three axes. Okay, now see. OX, OY, and OZ are the three mutually perpendicular axis. ABC is the standard or unit plane whose intercept on the three axes are small a, small b, and small c, right? The plane DEF makes intercept as MA, NB, and PC. MA, NB, and PC. Here, coefficient of A, B, C, Y's M, N, and P are called Weiss indices. So in the above diagram or previous diagram, M and P are called Weiss indices. Remember this. These that are called Weiss indices of the crystal plane. Okay. If the intercept, that is 2A, 3B, and 3C, the Weiss indices are shown as, that is M and P are shown as 2, 3, 3. So 2, 3, 3, M and P. Okay. For the crystal plane DEF, the intercept are OD, OE, and OF. OD, OE, and OF. If the plane is parallel to one of the axes, its intercept on that axis is considered, or that is infinity. That is at infinity. If intercept of a plane are 2A, 3B on x and y axis is parallel to z axis, then Weiss indices are written as 2, 3 and infinity. That's the M, N, and P. P is infinite now. See, because that is parallel to the z-axis. In such a cases, the base indices are inconvenient to use. In this situation now, base indices are inconvenient to use. Okay, so you cannot say there as that plane is at infinity and all that. Okay, so you need to replace the base indices with by the Miller indices. Okay, now Miller indices are obtained by taking reciprocal of base indices, multiplying them by the least common multiple. Okay, you are taking what we are taking reciprocal of base indices and multiply them by least common multiple, LCM, okay, of the base indices, and finally expressing the Miller indices in the form of simple ratio. We are expressing the Miller indices in the form of simple ratio, that is HKL. Now remember this. Okay, Miller indices are HKL, base indices are M and P. Now, HKL are called as a Miller indices of the plane. Now, from first example, from here, if we take 2, 3, 3 as a base indices, so in that case, how we can obtain the Miller indices? So what we are going to see, this is what your base indices, okay, in the first case. So 2, 3, 3 are the base indices. Now, by taking their corresponding reciprocal, how you are going to write 1 upon 2 as to 1 upon 3 as to 1 upon 3. So what is the least common multiple? It's a 6 now, right? So multiplying them by least common multiple, what we get? 6 upon 2, 6 upon 3, 6 upon 3. So you will get here now 2 3s are 6, right? So here 3 2s are 6, 3 2s are 6. So 3 2 2 are the Miller indices, are the HKL, are the Miller indices. Okay, so it's a very easy to understand. Very easy to understand. The plane DEF is designated as a 3-2 plane. The plane DEF as a designated as a 3-2 plane. It is easy to understand that the unit plane ABC has Miller indices 1 1 1. If a plane intercept any axis at infinity, the Miller indices of the plane for that axis would be the 0. Right now, see, if you have 1 0 0 plane, if you have 1 0 0 plane, in that case, that which plane is there? ABCD plane is there. Here, if you see in the diagram, so how you can write here the make an intersect. Okay, see now on x-axis, y-axis, and z-axis, what happens now? See, the plane ABCD in figure 9 makes an intercept at A on the x-axis, but it is parallel to y and z-axis. The ratio of intercept of a plane is A infinity, infinity. Okay, so base indices are 1 infinity, 1 as to infinity, as to infinity. So Miller indices are 1 as to 1 upon infinity, as to 1 upon infinity. So that is 1 as to 0 as to 0. So this is what the 1 0 0 plan. Similarly, you can find out 0 1 0 plan or 0 0 1 plan. Okay, what is 0 1 0 plan? 0 1 0 plane means that the plane is parallel to x-axis and z-axis, but that cuts the y-axis. You can see here in the diagram. Now this is okay. This is the plane, okay, which is called as a 0 1 0 plane. Okay, or 0 0 1 plane. 0 0 1 plane means that is parallel to x-axis and parallel to y-axis. Then which plane would be there? Yeah, this is the plane which I am showing you in the figure. Okay, this is the plan. Okay, that is a 0 0 1 plan. Now 1 1 0 plan. This plane. This is cutting x-axis and y-axis, but it is parallel to the z-axis. See, this is parallel to z-axis, but it cuts the y-axis over here. It cuts the x-axis over here. So what is that? A, B, and infinity. As we know that that can be written as a base indices as a 1:1 infinity, or we can write in the Miller form 1:1 upon infinity, that is 110 plane. In the same fashion, you can write as a 011 plane or 101 plane. Okay, so very simple. And the last one, this is the plane cutting all the axes. It is cutting x, y, and z axis. So you can see here, you can write these indices as that is ABC over here. Okay, the intercept ABC. So here 1:1:1. Miller indices are also there as a 1:1:1. Okay, so this is what the 111 plane. Okay, so this is what the all regarding unit first. All three topics from unit first are finished now. Hope if any query will be there to you, you will ask me on WhatsApp group, or you can call me directly on my phone number. Okay, so after this lecture, I'm going to start the unit second. Okay, so from unit second, half of the part belongs to me, while half of the part belongs to Bhagat sir. Okay, so which half part I'm going to show you. Okay, that again I will tell you. But see here, this is chemical bond and reactivity, that is of 7 lecture part. Okay, that I am going to cover in the further lectures. Okay, so thank you. This is all for this lecture, and remaining I am going to continue in the next lecture.